We're given another quadratic function, and we're asked to find the vertex, the axis of symmetry, and the x-intercepts again. We can start with the x value of the vertex. The formula that we use is negative b over 2a. In this case, our b is 7, and our a is 4. So I'm getting an x value of negative 7 over 8. And right off the bat, we have our axis of symmetry. And now we need the y value of our vertex, which we get by plugging the x value into the function. There it is. I plugged negative 7/8 into the given function. And we need to simplify. I'm going to square 7 to get 49. I'm going to square 8 to get 64. The negative squared becomes a positive. 7 times 7/8 is 49/8. And let's see, we can think of this 4 as a 4 over 1, of course. And this 4 can cancel with the 64, leaving a 16 in the denominator. And we end up getting, which requires some common denominators. I'm going to multiply this one by 2 over 2 and this one by 16 over 16 to make all of my denominators 16. 49 minus 98 minus another 16 gives me negative 65/16. I don't think that reduces any further, so we have our vertex. The x value is negative 7/8. The y value is negative 65/16. And the last thing that we need here are our x-intercepts. We can find the x-intercepts of any function just by setting the function equal to 0. Again, it would be nice if we could factor this, but it looks like this can't be factored, so we are going to have to use the quadratic formula. Here we have a equals 4, b equals 7, c equals negative 1. We plug those three values into our quadratic formula, we get, and then we need to do some simplification. 7 squared is 49. 4 times 4 times negative 1 is negative 16, but then you have minus and negative, which turns into a plus 16. 49 plus 16 is 65, and I don't think that square root of 65 can be reduced. So we have our two x-intercepts. Negative 7 plus the square root of 65 over 8, comma 0, and the point negative 7 minus the square root of 65 over 8, 0. Okay, I think that does it for that problem.